Hi, Brian. Welcome to the 100X show.
Thanks so much for having me.
Brian, just to kick things off, the first question I have for you is about your background and the background of your core team. This is the question I'm trying to assess founder market fit and also the ability of your team to perhaps solve problem as they arise. So I've already mentioned Layer Zero to our community, but just to kick things off, I think your background will be great addition to that.
Sure. Yeah, sure. So, uh, us three, the three founders, have known each other for 16 years. So we went to university together. We all started working in a IEEE testing and conformance laboratory doing early internet technologies. So I was voice over IP, Caleb was DSL, Ryan was data center bridge. My background is pretty eclectic. Computer science background. I dropped out after 3 years of school. Played poker professionally for almost 8 years. Was one of the best heads up no limit players in the world during that time. Left that to start a company with my two co-founders, actually, that we ended up selling 2 years later. I then wrote some machine learning models and showed it to a friend of mine. I was writing models to project baseball. I showed it to a friend of mine. He said, "Oh, you have to talk to my friends. They did work on baseball when they were at MIT. Like, they'll be super interested." So I showed it to this group. It was this conglomerate of MIT PhDs that just formed this company, Row AI. And they're like, "Oh, this is amazing. Like, we have someone you need to talk to." And so they schedule a call for the next day. When I get on the call, that person was Billy Beane. So the founder of Moneyball, the GM of the Oakland A's. And I ended up doing work for a bunch of the pro baseball teams and selling those machine learning models to some of the pro baseball teams. From there, I started a company in the Valley with the first ever engineer out of Andreessen Horowitz, a couple guys at a Google, that got acquired by people. And then me and my two co-founders again took a year to do independent research that got picked up and published by Noam Brown and Facebook AI Research. So I've been in the space since 2013, basically full-time since end of 2016. Both of my two co-founders, Ryan and Caleb, are even much more technical than I am. Ryan was 1588 precision timing at the sub-nanosecond level, co-authored DRR AWC, which was an algorithm for packet fairness, rolled out in Cisco switches all over the world, significantly changed the trajectory of high-frequency trading actually at the time on the hardware level, like at the switch level, which was super interesting, really, really interesting research. And then obviously was like the primary driver behind the architecture in our research with FAIR. So yeah, highly technical team, built a bunch of stuff, typically like hard problems, all pure technologists at heart.
Yeah, just to double click on this. So I found the whole architecture of Layer Zero quite novel and very simple. So what was the inspiration behind coming with that idea? What was that moment when it clicked that okay, we are going to use Oracle and Relayer and Lightnode to kind of communicate between different chains? Like, what was that aha moment for you guys, and what were you working on?
Yeah, I mean, so really we had spent 18 months of just kind of like hacking around. We did everything from writing on-chain trading strategies for hedge funds when DEXs like first got introduced. So you're talking like IDEX and sort of that sort of era of things, to like stripping apart portions of Geth and like trying to write parts for custom node discovery to make faster propagation while we're doing ARB and triangle ARB. So we're just like playing with the bounds of the ways that different pieces of the technology work around the system. And ultimately, it was at this time where everything, more or less everything, lived on Ethereum. Like Polygon existed, and then all of a sudden Binance Smart Chain came, and every single day we're reading articles on like, oh, like there's more traffic on BSC than there is on Ethereum, and like all of this stuff is happening. And so we really just started to say like, oh, like that's kind of interesting. Like, what could you actually do to create something like a game or something that kind of lives on both chains? Like, what would be a cool idea to just build? And so we were just tinkering. And then in doing so, we realized like there's literally nothing that like lets you do this. There was like, Polygon Bridge and a couple others, but there was nothing at the time with the state everything was in that, we would trust millions of dollars to, let alone like tens of billions. And so that's when we really just started digging into like, oh, maybe, okay, maybe you could use an Oracle to do this, but then like everything is in the hands of like this Oracle, and like if the Oracle is corrupted, like that's this huge existential risk. Like, can you really just take some off-chain Oracle and allow it to control everything? Like, what about like the IBC style? Like, okay, Lightnode's like totally impractical for an EVM system. And like, we started taking all the components of the other systems, and then we just like stopped looking at what existed and said like, okay, like from a technology layer, like what makes sense when you're thinking about this, like from first principles, and then like from an application, like what would you actually want to build out? What do you need? And that's when we really came up with like the idea of like, okay, like most applications are actually willing to like externalize or price some risk, but like you need to basically give the applications who are not the ability to cross-reference, the ability to basically play a role that is allows them to validate every piece of their own transaction or like a piece of that state, but at the same time not be a single point of failure for the applications, for the users using the application. And that's really where we drove down to like, okay, how do you reduce, like we came up with the ultralight node, which again was this like ad hoc block validation process.
So during that time, we already had some interoperability projects like, let's say, IBC, Polkadot, Thorchain. Uh, just to zoom in on this, like what were some of the problems you were seeing there, and how I think this would be a good segment now to kind of segue into how Layer Zero is trying to solve those problems.
Yeah, sure. So, I mean, broadly, we put everything. So, when we looked at everything, everything in our eyes fell into two categories. So, Cosmos IBC is a great system. You run an entire light client from one chain and you run it on the other, and vice versa. So, you maintain the full state. And it's like very, very secure. It's a very good system, but it's completely impractical when you're talking about an EVM. Even to do it from one chain to an EVM would be, $100 million a day or something per chain that you wanted to do. So, like, that was out the window immediately. And then everything else reduces to what we describe as a middle chain. So basically, you have two chains. They're totally atomic in state. You want to do something between them. You're going to write a transaction on the source. Some consensus mechanism is going to live in the middle. Like you'll have some threshold thing that sits there. And then you're going to have it's going to come to consensus, and then it's going to write a transaction out. And that was the big issue, was ultimately that chain was the signer on the destination chain, which means if that chain was ever broken, if its consensus mechanism was ever corrupted, whether an economic attack, whatever it might be, everything was gone. In like first systems, when you're talking 500 million, a billion, maybe a couple billion, fine. But when you're talking about 10, 20, 50, 100 billion, this starts to get really, really, really scary. You're creating, effectively like the largest honeypot the world has ever seen. They typically like don't, there's a lot of issues with them. One is that it has this really adversarial property of, okay, maybe you have this mechanism and this secures $5 billion, right? But then like Uniswap opts in and now it's 20 billion. And then Aave opts in and now it's 50 billion. And like every new application opting in is actually creating this adversarial incentive for every application prior. It's making their security worse unless the bond within the system is growing like non-linearly to the amount that's being secured. And that would be very capital inefficient and has never, ever been the case. So, this model where everything, and that's, you're talking about like pure risk too. That's not even talking about contagion. Like many of these systems are going to be hooked up to things like that allow you to mint a token on the other chain. And like when that thing is corrupted, not only can it steal every thing in every liquidity pool that's attached to it, but it can mint unlimited tokens. And then with those tokens, you can go on the dexes and you can drain all the liquidity of anything tied to it. It's real existential risk, massive contagion. And so we didn't think there's any viable way to scale that method long term. It can go to a certain point, and I think most of them have gotten to like about that point, but it can't scale beyond that. And that was really our big concern, was you don't ever want to have some central point of failure. Consensus is hard enough as it is. Look at the primary layer ones, and you're going to see like pretty regular like reorgs happen. Deep reorgs happen on some of these chains. And so when you're talking about like, and they have all of the incentives that you need to have proper consensus. And so like when you're talking about a single chain that sits in the middle, has none of those incentives, and all that it does is validate messages, like it's very, very hard to ensure that that consensus mechanism is not going to be corrupted for even a matter of a couple of blocks, because that's all it takes. As soon as it's corrupted for any period of time, it has the ability to arbitrarily send messages to every application on every chain. So again, just like pure cataclysmic existential risk.
I think now will be a good time to kind of decode Layer Zero. So, giving us a brief overview of how it works in from a macro standpoint, but also decoding the communication flow that allows cross-chain communication. So, if you're kind enough, if you can explain to our audience some of the things like valid delivery, some of the architectural components like endpoints, Oracle Relayer, and how all of these things fit into the puzzle, and we can spend some time just exploring this.
Perfect. I'll start at a really high layer, and then I'll work my way down. So the highest possible sort of view, if you're an application and you're building on layer 0, you implement exactly 2 things and that's it. So you implement send and receive. So as an application, you can think about it as you think about like packets on the internet. You're sending some generic bytes array, some payload to a contract on another chain. And when you get it on the other chain, you're interpreting those bytes however you want. So that means really, when I say generic messaging, you can do anything that you can write or do on chain, you can do at layer 0. There are no restrictions at the technology layer. It's purely the most extensible primitive you could possibly have. And so what that means is you can arbitrary contract invocations across any chain. So this could be something very simple like maybe it's add liquidity here and subtract liquidity there. That's how Stargate works. It could be something like you earned an achievement in the game here and like your metadata of your NFT mutates over there. But it could be something very, very complex. So that's one of the nice things about layer 0 is it allows you to take a complex series of transactions and bundle them up into one single transaction. So this might look like we'll take 6 transactions across 2 chains. It might be like unstake, swap, initiate a bridge, claim a bridge, swap, and stake. And now you can compress all 6 of those into one transaction. The user only ever signs one transaction. They pay the gas upfront on source for all of it. So if they're going like Ethereum to Solana, they don't need to have ETH in their wallet and Sol in their other wallet. They just have ETH. They just click and the whole flow gets executed. So at a very high level, that's what's happening, right? You just have contracts on any chain sending messages to each other. This can be SushiSwap and Uniswap. It can be Aave. It can be, any application, however you think about that. It can be marketplaces and wallets, aggregating sort of the ability to buy or farm or do any of these things across every single chain, whatever that looks like. So from the very highest layer, that's what it looks like. But then you go down. And so what's actually happening is you have an endpoint on each chain. And an endpoint is it's a library of smart contracts. That's all it is. Nothing special. It's not off chain. An endpoint is just a library of smart contracts that lives on each chain that validates incoming messages, validates the proof, and then passes it on to the destination contract. And then it allows the sending contract on the source to interact with it to send a message out. So that's all it does. It's basically the one facilitating, sending, receiving, and validating messages. And so that lives on every single chain. So there's one on Ethereum, there's one on Polygon, there's one on Avalanche, and so on and so forth. And every application interacts with that endpoint. Now, what's happening when you send a message? You've sent some payload and you say, hey, I have this message, so I'm going to do a swap. And I want to do it, I've done a swap here on whatever, SushiSwap on chain A, and I want to execute the other leg of this swap in 1 inch on Polygon, all right? That's the pathway that we're going. So it hits the endpoint. What happens is this breaks up this piece of state data and triggers the oracle in the relayer and says, hey, I want you to pass this data to that chain and that contract after this many blocks. So let's say we're coming from Ethereum, let's say 35 blocks. So after 35 blocks, you're going to hit that chain and you're going to tell it this. So the oracle takes the block header, which contains a receipts root. The relayer pulls the transaction proof out of a full node. So EVMs, it's a Merkle-Patricia proof, or Merkle-Patricia tree. Submit those both to the destination chain. On the destination chain, in the contract,
can you explain what Relayer would be? So, what is Relayer in this case?
Yeah, absolutely. So, Oracle and Relayer are both a bit of a misnomer. They can be anything. So, think you have 2 arbitrary systems, and you're breaking up the state data between a block header and a receipts root. In Oracle, we are working with sort of all of the major oracles, so whatever you would think. But it can be anybody. Both are open and permissionless. Anybody can play the role of an oracle. Anybody can play the role of the relayer. But the important part is that applications must opt in to using a specific oracle or relayer. So what that means is that, in a traditional system, you have an oracle. The oracle breaks, everything's gone. In this case, you have that same system, and let's say your oracle's, whatever, a very famous oracle, it maybe costs $2 billion to break. You could affect like $5 billion in damages, and maybe at some point that happens. But now you have an oracle, and you have this like subset of relayers. And even if that oracle becomes malicious and is colluding with, let's say, relayer A, well, only applications using exactly that oracle and relayer A would be affected at all. So anybody using relayer B through Z, anybody using any other oracle, anybody relaying their own transactions are totally unaffected. So you take this massive pool of risk and you heavily shard it. It still costs $2 billion to break that oracle I was describing. But now instead of winning all 5 billion that was protected by the system, you win like 1/30th or 1/300th of it based on the Oracle and relayer split. So you only win like a very, very narrow shard. And it also gives applications the ability, say most applications, they're small. They're going to be totally fine pricing or externalizing that risk and saying, listen, I'm okay using Chainlink as my Oracle and Coinbase as my relayer. That's totally fine. I'll live with the assumption that both Chainlink and Coinbase are not going to be simultaneously malicious and colluding against me, right? But then you have
So Brian, just to
Yeah,
expand on that, so I get that, like middle chain, you have less security. With this setup, you have more security. You have independent Oracle and Relay. But do you think there could be higher costs? For example, in this case, let's say you have Coinbase and Chainlink. Do you think
Yep.
just using both of them, incentivizing both of them to communicate from one chain to another, do you think one of the trade-off could be slightly higher cost in order to communicate between chains?
So I think broadly, the way that you can think about it within layer zero is you can effectively create this frontier. Imagine drawing a line that lives on cost and security, right? Like all the time you will if you want more security, it will cost more. And now you allow applications to basically pick a point on that line. Do you want to have a single Oracle and Relayer that are very simple and maybe not that secure? Like you can pick a point that's extremely cheap. Do you want to have a lot of security? Well, now you can pick an Oracle and Relayer that maybe is like a very broad distributed system that costs a lot basically to secure, right? At the end of the day, in crypto economic systems, like security comes with costs, right? Like you're paying for security. The Ethereum validator set, you are paying for security. And so basically, rather than defining one single set of parameterization and saying, hey, this is a thing, everybody opt into it, and this is the cost. Now you say, where do you want to live on cost and security, and pick the sort of arrangement or the configuration that makes sense for you. So the example that I always give in the other systems is all the parameterization lives at the technology layer. So you have one system and everybody's going to opt into this. And it doesn't matter if you're like a tiny game and you're verifying on the chain B that you own a copper sword on chain A, or you're transferring $500 million. You're both paying the exact same amount for security. And so what that means is either somebody is wildly overpaying or somebody is not getting nearly enough security. Like there's no way around it. There's no way both of those should pay the same for security. So when you're opting into the same system, the same set of parameterization, you're either falling way too far on one side of that line, right? And the way that we think about this is you want modularization. You want applications to be able to set this parameterization themselves. So yes, absolutely, this could cost more, but it could also cost less. But I think in general, there is just this, it's a broad thing of cost and security. And like, where do you want to live? Pick your point.
Yeah, that was a great point. Yeah, it clarified for me as well. So you mentioned two application with the Stargate. You have bridging of assets, and you also mentioned an application with NFT that says like there's a change in state of an NFT in one place, the other chain something happens. So let's imagine hypothetically we are in 2025. What other applications can you imagine people building on top of layer zero, or you guys building on top of layer zero?
Yeah. I mean, there's already like on testnet, we had 560 contracts. So there's tons of developers built on testnet. Lots of people are building right now. Lots of people are integrating. So we're going to see all kinds of things. But some things I'm particularly interested in right now is a really big issue with wrapped assets. So the problem with wrapped assets is if you want to go from, excuse me, let's say Ethereum to any other chain and you want to use your ETH. What happens now is you lock your ETH here and you mint a synthetic ETH over there, right? So you have WETH. This is what just happened with the Ronin hack is you had a bunch of locked ETH so that it could be used in Ronin. But the same thing, if you're on Sol and you want to use your Sol somewhere, you're going to lock up your Sol and you're going to mint a synthetic Sol somewhere else. And the question is, do you actually need to have Sol, the Solana token, on another chain? Do you need to have it on Avalanche? Do you need to have it on Ethereum? Like, no, you don't really need it. What you want is you want the ability to use your spending power of Sol on another chain. So what you want is the ability to collateralize Sol and borrow against it. And so the issue with wrapped assets is if you have $10 billion of outflow from chain A to chain B, you will always have $10 billion of permanent risk. As long as those assets are in circulation, if that ever gets hacked, if there's ever any issue, everything's gone, all 10 billion. But what you really want is the ability not to have these wrapped assets in these standing risk. You want the ability to just collateralize your Sol on Solana, and borrow directly against it on Polygon or Avalanche or Arbitrum or Optimism or wherever it is, right? And the same thing for ETH and everywhere else. And so I think that's something that is very exciting to me. Yeah, so that for sure is very exciting for me. Is the ability to have that sort of cross-chain collateralization and remove the need for wrapped assets, because I think wrapped assets are one of the largest risks broadly to the ecosystem. It's in some cases it's inevitable, but I think in many cases we can avoid it, and I think we absolutely should whenever we can. There's tons of other things, super creative games, super creative like abstraction. So wallets, where now you can have a wallet where if you want to go like asset A on chain X to asset B on chain Y, you can do it within the wallet. If you want to go from like this farm that pays 20% to this farm that pays 40%, you can do it in the wallet without the user knowing what the underlying chain is, what the underlying gas token is, needing to have gas or do any of that. All of that can be abstracted away. The user kind of one interface, you can kind of create this Robinhood of crypto. And so that sort of consumer adoption and the ability to make that more accessible, also hugely exciting.
You did mention NFT, gaming, metaverse, and I think during Avalanche conference you also mentioned it. Maybe some of the entrepreneurs or some of the founders came to you with some crazy ideas that they're thinking about. Maybe if you would like to share some of those crazy ideas, just to kind of broaden our horizon here.
Yeah. There are some very cool ideas. I don't want to give away too many people's ideas, but one that I've heard multiple times that I thought was very cool was this: the ability to play a game on whatever. Let's say you're on an Avalanche subnet, you have a game, you're issued there, and you're playing this game, and you have your Twitter profile picture is this PFP that is synced to Polygon or to Ethereum, right? What you can do is, as you earn achievements in the game or whatever you do, as things happen in the game, you can propagate messages back out to mutate the metadata of that NFT on Ethereum or Polygon, which will in turn automatically sync within a matter of a minute or two at the refresh rate of your Twitter profile picture, and your profile picture will automatically be upgraded. So something happens, you kill a boss, you do something, and like now your person has a crown on your Twitter profile picture, and people comment on it, and like that sort of social engagement, that sort of interop and like connectivity is really, really, really cool. So I think there's going to be this were just people like very early on throwing around ideas. I think there's going to be a ton of things you see around it.
Yeah, that is pretty neat. So I was going through your Medium article. Like one of the articles was about IBC on top of Layer Zero. Like how will that work, and what's the vision there?
Yeah. So I think mostly when people talk about IBC, there's like two different things, right? IBC started as a messaging standard, just like in the internet. We need messaging standards, or maybe it depends. In the internet, we definitely need a messaging standard. But broadly, like if I write an application to myself, it's very easy. I pack the bytes a certain way, and I know on the other side, like here's how to unpack the bytes. Here's how I structured everything. Here's how to unstructure the data. When I don't, now if there's 10 of us and we're all talking to each other and we all put things in different ways, well, like code doesn't read like plain English, right? It's not like you're writing a letter. You're doing things, and there isn't really a way to make it just arbitrarily know what that is. So let's say we were doing something simple. We're sending like name, date, and then like some set of instructions. And I send mine in the order of like name, date, instructions. And then you send yours in the order of like instructions, date, name. And then like everybody else just mixes however you do this. And we send it. And then each of us are trying to interpret it. And we're like pulling the wrong things, right? Everything is just broken. Nobody knows how to communicate. And like broadly, that's the state of the world, still the state of the world now, more or less. And so IBC created a messaging standard that was a way to structure this data so that all the applications have a formalized way of here's how we're going to pack the bytes, just like the internet did, just like packets on the internet as applications and servers were sort of co-communicating. And so now, like that's much needed, and that's the IBC that like we think about, right? Is IBC the messaging standard? Then you had IBC where they realized, they were really early. This is like 4 or 5 years ago, and there was no way to communicate between chains. So IBC said, oh well, we have to actually make our own transport layer to be able to send any messages, because we can make the standard and we know to format the message. But how do we get it over to that chain? How do we communicate? And so they created their transport layer, which is effectively, again, like the on-chain light clients, right? So you have two chains, you want to communicate. I'm going to take all my block headers, and write them to your chain. You'll write them to my chain, and then anybody can just easily validate a transaction across. So now when you're sending messages, you can do that. So we released this article, and we basically said we will use layer 0 as a transport layer, IBC as a messaging standard to allow EVM and sort of other chains externally to conform to ICS standards and talk to sort of these IBC enabled apps on the Tendermint ecosystem.
Yeah, that makes sense. It clarifies it further. So one of the questions I have is, how do you? I know it's this question is a bit of an early one, but how do you kind of see the competitive landscape of cross-chain messaging going forward? I know you guys have one competitor called XLR who's also doing same thing. So what makes you differentiated, and what you guys feel will become your moat? Like, what is that one special sauce that you guys have that will make you different and create that competitive edge?
Yeah. I mean, I think the easiest thing is like go back 6-8 months in time before we announced, right? Go look at the archives of every website of everybody who you might consider a competitor. And every single one of them was a bridge. They're a bridge. They do value transfer. You're a user. You take a bag of money and you like walk over the bridge and land over there. So you lock it up, you mint it over there. And like, that's what they did. And we announced and we said, you know what? Value transfer is kind of dumb. It's just it's just a special case of generic messaging. Anybody can do value transfer if you just have the messaging format, right? Like all we care about is generic messaging. And if you want to build value transfer on top, that's fine. It's just, you just structure the message in a certain way. And so, we built that. And we said pure generic messaging, and fast forward a couple months, and every single person who was just a bridge is like, and now we definitely do generic messaging, right? So now that's all anyone talks about is being communication protocol, being a messaging layer. But that's all new. They're really like taking something that maybe wasn't designed for this and sort of adding it on for most of them, not for everybody. Some people have like kind of interesting ways to do this, but most people were focused on value transfer. Right now they're like, okay, we got to figure out how do we send messages and do this. I would say the biggest advertisement I can give to myself or us is just use the products, right? Like that's it. Try to build on it. We've had people who are months into building on basically every other system who threw away their work to build on us after they spent some time with the docs and playing around. It is incredibly easy to build on. You go on Stargate and it's as advertised. You click a single time, one transaction, whole thing gets executed. It's going to pop a new wallet on the other side. You're not going to think about source and destination gas. You're not going to think about anything. Go to, I don't know, the example I give is like Wormhole. Try to bridge, like that's the best. Go try to bridge USDC from Solana to Ethereum using Wormhole, because your process will be, you'll sign 8 transactions on the Solana side. You'll wait. You'll end up on the Ethereum side. You'll have to switch your wallet to your Ethereum wallet. You'll have to get ETH in that wallet. So like leave, go to some centralized exchange, get ETH, put in the wallet, claim your transaction, and you will have Wormhole wrapped USDC, which has zero liquidity and you cannot do anything with it. You'll realize you've made like a terrible mistake and you'll just have to walk the entire process back to unwind it. And that's for a user. And a user can bear a lot of pain. When you think about building that into an application flow, like, does Sushi want that to live in the middle of their application? Like, is that the experience you're going for? So no. I mean, broadly, like I try generally, like I don't care that much what other people are doing. I don't care about other constructs. I don't think about competitors very much. I think about what we were doing and building like the best possible system to build on top of. When people ask me the question, like the simplest thing is just go use them. And I think it's pretty
apparent. Yeah. That's how I discovered Layer 0. I saw your video, 10-minute video on how Stargate makes life easier. You just need few clicks to bridge assets rather than 50 clicks with the other way around. I think there's also a proposal on SushiSwap that they want SushiSwap to kind of implement. Yeah, so maybe mention that.
Yeah, I think it's just passing now. So yeah, SushiSwap set up a proposal to integrate Stargate. And so what that means is, so Stargate, we didn't really dive into it, but it's a liquidity transfer layer. So layer 0 is generic messaging, but a lot of times you need the ability to pass value between chains. So a really simple example of this is you're a yield aggregator, right? So you have a farm here and you want to like unstake 10,000 USDT. You want to stake it in some new farm that's on this other chain over here, right? So you're going to take it out here and take it there. But the problem becomes, how do you actually get that tether from this chain to that chain, right? People used to go and send it to a centralized exchange and then withdraw on the other chain, or you would have, you might have your user leave and go to some external bridge, but they get like some wrapped version from the bridge that they're using instead of like the canonical version. And so it was really painful. And so Stargate's entire point was just to alleviate this. So now the yield aggregator wants to do that. They wrap those two contracts, so unstake and stake, compose Stargate. What's happening is unstake, add to Stargate liquidity here, subtract there, and stake. And that whole thing is done in one transaction. So when you're talking about Sushi, it's the same thing, but with swaps, right? You want to go from asset A on chain X to asset B on chain Y. Well, you swap like ETH to USDC, you bridge the USDC over Stargate, and then you swap USDC to asset Y on the other chain, and you are done. And all of that happens in one single click. The user doesn't need to leave and use any external flows. They don't need to have source and destination gas. And for SushiSwap, the integration it's like 30 to 100 lines of code. It's literally wrap your two contracts, compose Stargate, and you're done. And so yeah, that was really the primary driver of Stargate, and that's the SushiSwap integration, is to allow this one click process to be able to connect, because Sushi's on 16 chains. They were like one of the earliest sort of multi-chain applications, but they haven't been connected this far. And now it allows them to basically, now you can hop between any Sushi, and now Sushi can really be sort of on the frontier of driving that, which is amazing.
You guys just announced that Series A plus 135 million was raised. What do you guys are planning on using those proceeds on? Like, how will those proceeds be used with regards to development of Layer Zero?
Yeah. So right now we've loaned out all of the money. So basically we've loaned it out at 8.5%. It's less than our burn. So we have like positive burn. So we basically have infinite runway. We have the ability to build and focus on building more than anything else. We don't have to worry about you don't need to worry. We're not burning through the money. We're not doing anything. No, everyone asks us, like, we've spent $0 on marketing, $0 on promotion, nothing. All of our money goes into the people working on this. We're a team of 25 right now. And so no, the money is lent out. If we have a strategic use for it later, we will. But right now, like, we have the ability to build and work on something amazing for a very long time. And that's what we're going to do.
So I've seen with Layer Ones, you have different ecosystem development funds. Like in the future, can we kind of see that happening, or am I getting a bit ahead of myself? So let's say Avalanche have a fund to kind of give it out to developers in terms of grants or in terms of
Yep.
seniorize that.
Yeah. Layer Zero will absolutely have a grant program, 100%. We are extremely developer focused.
Yeah, that's great. One question I also had for you was about the token. So when will we have this zero token? If that's the acronym for it, what token utility will that serve, and who will be the end users of those tokens?
There is no information on the economic structure of Layer Zero right now. So there is, plenty of information on the economic structure of Stargate, but at the moment there's been nothing released on the economic structure of Layer Zero.
So our audience can assume that in the near future there won't be a token for Layer Zero.
I think there are some Twitter sleuths who have poked around in code and are sort of, people have their own opinions right now. For now, we have not announced anything around.
All right. Apart from that, what are some of the other partnerships you guys are working on, and maybe perhaps share some of your roadmap ahead?
Yeah, I mean, for us, it's really, when you're talking about partnerships, it's everybody. We want everybody who's thinking about multi-chain to be thinking about us. And so we are talking to hundreds and hundreds of groups right now who are integrating. Our priority is definitely sort of the most active chains and the largest protocols. We're building as many resources as we possibly can to make bottoms up integration just easier and easier. But we're really focused on top-down adoption as well, and allowing these existing applications to have a safe and secure way to move into this multi-chain construct. It's really like the amount of people has been really quite staggering. Things we've announced that we've talked about that. When you're talking roadmap, like, we're going to be connecting almost all of the Avalanche subnets. We're going to be on Solana and Terra very soon. We're exploring paths to other sort of, our goal is to be everywhere. And so you can just expect that we'll be everywhere as soon as we
So
possible.
apart from EVM, non-EVM, did you guys face any challenges on that front? And like, we have been very bullish on Layer Zero token metric itself, and even during this discussion. So apart from that factor, do you see any other significant risk facing Layer Zero going forward in the future?
Yeah, I mean, I think definitely EVM to non-EVM is always a challenge. Like, there's different proofing mechanisms. You need potentially proof translation. You need like there's some really interesting sort of technical things that go into it. So those are always like fun problems to work through. In terms of challenges, like for us, we really just think about like how do we make this as easy as humanly possible to build upon over time, like things. So we've right now we're in self-proclaimed beta, and what beta means to us is a limited subset of oracles and relayers. And so in time, one thing that we will definitely be focusing a lot of energy in is creating this really broad spread of both relayers and oracles. We have, there are probably 30 different people, at least sort of large institutional entities who have expressed interest in running relayers. And so we have like the ability to do that. The goal is just we need to create this model that makes it much easier for someone to do. Maintaining a relayer is like not super trivial. You need to be able to have be able to run full nodes and pull transaction proofs out of full nodes and so we will be open sourcing reference implementations. We'll be making that easy. We'll be making it much easier for people to migrate projects to like migrate their multi-sig to be one of these components. Lots of different things basically within that.
So I know I'm going to push you once more. I know there won't be any token, but imagine hypothetically if there was a layer zero token, what utility would that hypothetical token would have? Like if you feel comfortable answering that.
Yeah. So I mean, if you're thinking hypothetically about the system, right? You have this system that's a messaging system that interconnects sort of every chain, right? Your message is going back and forth, and you have to incentivize these systems that are providing security, right? So there's like a cost and security risk, and so in a hypothetical world, right? Like you need to have some fee that's basically attached. A lot of that fee basically needs to accrue into the parties who are securing this. So the selected parties, these oracles and relayers. Oftentimes, there's need to be like bonded systems. So you might have like the oracles and relayers be bonding certain value. As applications are then selecting them and like assigning value through the messaging fees, and there's this whole construct of economy that gets built around that structure, right? So most likely, when you're thinking about like what does this system look like and how do you do it, like I would be thinking about it around those lines.
Awesome. Yeah, makes sense. So Brian, before we conclude, is there anything that you might want to add or something we might have missed?
No, I think broadly this was like pretty good introduction to Layer0, the technology itself. I think again though, some of the most interesting parts to me are the developers. It's like what is being built, right? There's only so many things that I can think of to build, so I focus on building like the most extensible possible primitive, and then like everybody else will do things that are way more interesting than I could ever come up with myself. And so I think really like that's just the thing I care about the most. We are incredibly attentive right now to the developer community. So anybody who's building, anybody who's doing anything, but I think more and more it's just like I want to see what is built and how this is utilized on top of it. And I want to make it as easy as possible. And so I think anybody who is thinking about doing that, like just spend 2 hours with the documentation, like just poke around, like within 2 hours, you will be spun up, have contracts, ping-ponging messages back and forth. Like it is incredibly easy. We put a lot of time into making sure it is incredibly easy.
Yeah, I'm not a developer, but I can vouch when I went to Stargate, like the wallet, it also has this neat feature where your NFT in a small size gets uploaded. So I thought it was a neat feature, kind of also user focused in terms of UX and UI.
I'm glad you noticed.
Yeah. So thank you, Brian. Thank you for coming to the 100X show. It was a pleasure, and I learned a lot about Layer0.
Amazing. Thank you so much for having me.